According to a recent MIT study, 95% of AI pilots are failing. 95%. That is not a small miss. That's systematic failure. And it's not because AI doesn't work. It's actually because most businesses are approaching AI the wrong way. So in this video, I'm going to explain why most AI pilots fail and what you can do differently. If you're a founder, executive, or business leader looking to use AI, this video will save you time, money, and credibility. I'll walk you through the 6 most common reasons that AI pilots fail, and I'll show you how to avoid being part of the 95% that waste budget without driving business success. Okay, let's talk about some of the reasons why so many AI projects are failing right now. Number 1, lack of business case, strategic alignment, and KPIs. So I think that many AI projects, if not most of them right now, are failing at the problem selection step as opposed to the tool selection step. We'll talk about tool selection in just a minute, but let's focus on this problem selection step. Many executives and business leaders are getting very excited about artificial intelligence, large language models, and AI agents specifically. And they're saying, we need to use AI. We need large language models. We need AI agents. But they're not really thinking about what problem they're actually trying to solve. This is, I think, the wrong way to go about it. The right way to do it is to think about what business problem you're trying to solve. And maybe a little more specifically, what key metric are you trying to drive with your new AI system? Is it revenue or is it profit or margin? If it's revenue, are you trying to just get more customers in the door to drive revenue, or are you trying to increase the average revenue per customer? These are two different things. Are you trying to improve employee productivity? There are some productivity metrics like labor productivity that you can calculate off of some of your financial statements. Are you trying to increase customer satisfaction? There are tools and techniques that you can use to improve customer sat. And I should know a fair amount about customer experience because I did customer satisfaction when I was at Apple. So there's a whole variety of metrics, some that I just mentioned and a variety of others that I didn't mention. You need to figure out which metric you're actually trying to drive and what business problem that you're trying to solve. And only after you do those things, then you can choose the right tool to drive those metrics and solve those problems. That actually leads us to our next point. So number 2, choosing the wrong AI tool. Not every problem is an LLM problem. LLMs are good at solving certain classes of problems, but not all of them. And if you choose the wrong tool, you are much more likely to waste money, waste reputation, you're more likely to have unmet expectations. So choosing the wrong tool can be very costly, but choosing the right tool gives you a much higher likelihood of success. Now, I will say that broadly, choosing the right tool requires quite a bit of experience. You need to know what the different options are, what the pros and cons are, and things like that. But there are some broad categories and some broad ways of thinking about how to connect certain types of tools to certain types of problems. So let me give you a quick rundown. First, we have large language models, whichever one I think is kind of familiar with right now. These are very good for text generation. Anytime the output looks like text, so a question and answer system, a chatbot, a coding copilot that generates code. Anytime you need to do translation or text summarization, LLMs are very good with text-based inputs, and they almost always generate text-based outputs. There's also an associated technique called RAG, where we take a large language model sort of at the center, and then we connect that to a database, either a traditional database, but more frequently now, we connect a large language model to a store of documents. We store these in something called a vector database. And what RAG does is it takes an input query, then finds relevant documents in a document store, retrieves that information, and then augments the query to help generate better answers. RAG is very good for knowledge retrieval and any time where you need to enhance an LLM with more context from documents, things like contracts, conversations that you've had in the past, emails, policies, things like that. Beyond LLM and RAG, we have supervised learning. This is essentially predictive models. So anytime you're trying to make an accurate prediction, things like predicting churn, predicting upsell or cross-sell propensity, predicting sales numbers, predicting responses to maybe marketing campaigns, you're typically going to use a supervised learning model. This is a traditional form of AI. Many of the best businesses of the last decade were kind of built on supervised learning. That includes companies like Google, Amazon, Netflix to some extent. This is a classic form of AI, and you need to have this in your toolkit. A different technique is unsupervised learning. It finds structure in data. So, very frequently, if you're doing anything with a strategic purpose, marketing strategy, product strategy, you can often use unsupervised learning techniques for those purposes. And then we also have AI agents, which I have said in the past, I don't think that these are quite ready for prime time yet, but they are getting better. We can kind of include in this any sort of agent or AI-driven workflow automation. You're going to use these very frequently when you have repetitive tasks with specific tools that are being used that could potentially be accessed. It's essentially taking a large language model and then connecting it to all of the other databases and document stores and software and tools, connecting it together with the LLM kind of in the center so it can reason about things and perform those repetitive tasks over time. This does take some training, meaning these systems need to be trained. We'll get to that a little bit later on. And beyond these four, there are still others, things like computer vision, where you're training a system to look at images or video and identify certain features inside those images and video. This can be useful for robotics and industrial applications anytime where there's a physical product. What I'm trying to get at, though, is that there are a variety of different tools and techniques from AI and what we would call machine learning, a classic branch of AI. There are a variety of different techniques. You need to understand which techniques solve which problems, and then choose the right tool for your problem. Okay, reason number 3, ignoring data readiness. This is actually a big one, and it's something that many people overlook because when they're using ChatGPT, they think they just need to type in their questions and ChatGPT gives them an answer. That's kind of the simple way of using it. What I'll say here is that almost every AI technique either needs data or could use it to give better answers. The classic version of this is with predictive models. Predictive models essentially always need a training data set. So if you are going to build some sort of predictive system, you're going to need data that is relatively clean. You typically need a large data set. The larger, the better in most cases. That data typically needs what we call labels. I'll maybe set aside what that means for a second. But essentially, predictive models need really good training data. AI and machine learning experts focus an enormous amount of their efforts on the data. In fact, the former head of AI and machine learning at Tesla said that they spend about 75% of their time just thinking about the data. Maybe you should start thinking a lot more about the data as well. But that's predictive systems. Large language models can also be augmented with more data. I kind of mentioned this previously with what we call RAG, retrieval augmented generation. Essentially, you take a large language model and then connect it to a database of documents or other information that can enhance the large language model's responses. We can go further into agents if you're building an agent. One of the reasons that agents fail very frequently is that they're not trained. In order to work well, agents typically need a little bit of training on a particular task. They also typically need some good training examples for tool use. If you give them access, let's say, to a piece of software or another tool, you often need to give an AI agent some training examples and train the agent to use that particular tool set. This is very frequently forgotten, but it's one of the ways to make AI agents perform better. So what I want you to understand here is that data is often the key to creating AI systems that are accurate, reliable, and trusted by users. Another thing that I want to leave you with on this point is that real AI experts know this, and bad or fake AI experts do not. So if you're talking to an AI expert and they're brushing aside concerns about data, or they're even forgetting to talk about it altogether, that is a red flag. Data is very important, so it's something that you need to watch out for. Speaking of red flags with so-called AI experts, this brings us to another reason for AI failure: lack of engineering discipline. Many pilots are really just demos. They're very brittle and they're sort of hacked together. And unfortunately, this is because I think a lot of AI experts right now are kind of hackers and they aren't AI engineers. I'm sorry to say this, but many of them simply just don't know what they're doing. They learned AI in a couple of weekends and then they're trying to pitch stuff to people that don't really know the difference. Real AI systems need engineering. Maybe a little more specifically, serious AI systems need to be validated that they work. So they need validation, they need QA, quality assurance, and they also need ongoing monitoring. This is actually somewhat similar to software engineering. It is not the same thing though. So if someone is a software engineer, they do not necessarily have the right skill set, but there are some similarities. Figuring out the right metrics to use, figuring out some test cases, and then setting up monitoring. Monitoring is closely related to what we would traditionally call DevOps and software engineering. There's a sort of related term now called AI ops or ML ops for machine learning operations. And effectively what that is monitoring these systems over time to make sure that they continue to perform well and they aren't breaking down. AI systems do break down over time. This is unlike traditional software where you typically kind of write it once and maybe there will be some new use cases that come in over time and you need to sort of update the software and make sure that there aren't any bugs in an ongoing way. But AI systems, if you build them once, they can actually degrade over time and you sometimes need to train them again or modify them in certain ways to make sure that they continue working for your business purpose. So serious engineering discipline is not optional. In fact, I'd argue that it's the thing that makes a difference between an asset that drives consistent business value and a debacle that costs you money and reputation. Next, reason number 5, lack of system learning and adaptability. The MIT study that I mentioned at the beginning noted that most of these AI pilots do not adapt or quote unquote learn over time. Now, in this context, learning has a very specific meaning. It comes from the field of machine learning, where we are training systems that learn how to take actions on the basis of incoming data. So good AI systems can and should learn and adapt over time as they get more inputs. Now, many users tolerate this lack of learning and adaptability with ChatGPT, although it does have a context window and it can sort of remember your past conversations, but often very imperfectly. ChatGPT and similar systems often forget things. Ideally, a good AI system should be able to learn over time and it should have a sort of memory. That's true of large language model systems. That is true, ideally, of AI agents. As I suggested previously, you should often train an agent to do a particular task, to use particular tools, to think a certain way. So that training and tuning is very important. And certainly in the context of predictive models, training and learning are really the whole name of the game. So if you want to avoid this pitfall and you want systems that actually do learn and adapt over time, you're going to need, as I said before, you're going to need the data because these systems, in order to learn and adapt, they need the right data in a vector database or a traditional database. They need training examples. They need tuning examples. You're also going to need the right talent, people that have the right machine learning and AI talent such that they know how to train these systems properly. There are all sorts of problems that arise when you start training systems. There are all sorts of failure points and ways that this can go wrong. So you need people that really know what they're doing. And if you talk to someone and say, hey, how can we train this AI agent to work better and to use our tools a little bit more effectively? And they say, oh, you don't need that. Forget about that. That is another red flag. They probably simply don't know what they're doing and don't know what they're talking about. So you're going to want to look for people that understand this point, understand the usefulness of training and system tuning, and have a skill set such that they know how to implement that. Okay, finally, the 6th major reason for AI project failure is organizational resistance and lack of change management. My main point here is even perfect systems will fail if people refuse to use them. So in some sense, even if you build a perfect system, your job is maybe only partially done. Change management is going to be almost as important as engineering the technology itself. There's maybe a couple of different points of failure here. First, if maybe the system has pretty decent performance, but it's hard to actually fit into a workflow for some reason, maybe a bad UX, or it's cumbersome to use in some way, the project is much more likely to fail. People simply won't use it. The same thing, I think, number two here is with training. If the system works very well and maybe it has a good user interface, but people aren't trained well to use it, then you can still have a project failure. And third here, I'll actually add one more thing, is if there's just organizational resistance. I've heard many entrepreneurs and AI consultants talk about this as they get further into an organization, start talking to people. The people near the top are very excited about AI, but as you get into the middle and frontline levels, people are very anxious about artificial intelligence. You're getting a lot of resistance, and some of that is very subtle. People maybe are just dragging their feet. So you're going to need some change management to make sure that when these tools are brought online, that people are using them, they are implementing these tools in their workflows, and that you're making people comfortable that you are trying to enhance their abilities as opposed to replace them. Okay, so let's recap. AI projects aren't failing because AI is inherently ineffective. AI projects are failing because many companies are skipping the fundamentals. They are choosing the wrong problem to solve. They are choosing the wrong tool to solve those problems. They have a lack of engineering discipline. They often have the wrong data or incomplete data. They're failing to train these systems such that the systems can adapt and improve over time. And unfortunately, they're also failing with change management. That's why 95% of AI projects are failing. But here's the good news. If you approach AI with strategy, discipline, and a focus on measurable outcomes, you can be a part of the 5% that are getting serious results with artificial intelligence. This is why I start every engagement with my new customers with a structured diagnostic, figuring out what problem they're trying to solve, identifying the key metrics, choosing the right tools, identifying the data assets that will be needed, and if they have those data assets, and so on. If you're curious and you want to learn more, click the link below. And if you liked this video and thought that it was useful, click like and subscribe and share it with someone else.